Fear is the oldest emotion the brain has ever known. It kept our ancestors alive, warning them of predators, storms, and enemies hiding in the dark. But in the modern world, fear no longer comes from claws or teeth. It comes from screens, from headlines, from comments, from glowing rectangles that whisper what you should worry about next. What once protected us now controls us. And the people who understand how fear works can quietly shape what we think, buy, and believe. This is the science of fear and how emotion becomes a weapon. At the center of every fear response lies a small, almond-shaped cluster of neurons, the amygdala. It fires faster than thought, reacting before logic has time to speak. When it activates, blood flow shifts from your prefrontal cortex, the part responsible for reason, to the muscles and heart. You're no longer thinking, you're reacting. This ancient circuit is why fear spreads faster than truth, because the brain doesn't wait to verify danger, it only needs to feel it. In politics, in marketing, in religion, and in war, fear has always been the most reliable form of control. Today, it's refined by data, amplified by algorithms, and personalized for every mind. To understand how, we'll explore 5 scientific mechanisms, each one proving how emotion overrides reason and how fear, more than logic, decides the future of our behavior. Let's begin with the first, the amygdala hijack. In 1996, psychologist Daniel Goleman coined the term amygdala hijack. It describes the moment when your emotional brain overrides your rational brain, when fear takes the wheel before logic can even touch the brake. When this happens, the amygdala, your brain's emotional alarm, floods your body with adrenaline and cortisol. Your heart races, pupils widen, muscles tense. This response evolved for survival, but today it's exploited for influence. Neuroscientists have shown that fear signals reach the amygdala milliseconds before the information even reaches the conscious cortex. That means by the time you realize you're afraid, your brain has already decided what to do. Joseph Ledoux, a leading neuroscientist at NYU, demonstrated this in the 1990s. He found that when people were exposed to threatening images or sounds, the amygdala responded even if they weren't fully aware of what they saw. The brain doesn't need clarity to create fear. It only needs a hint of danger. Today, fear hijacks happen not in jungles, but in timelines. Every notification that says "breaking," every thumbnail with red text, every story with a fearful face, they all activate the amygdala before you can evaluate the truth. This is why misinformation spreads faster than facts. Fear captures attention, and attention feeds algorithms. The more anxious people feel, the more they scroll. The more they scroll, the more data they provide. And that data tells companies exactly how to scare them next. In a 2019 study published in Cognitive Neuroscience, researchers measured reaction times in fear processing. They found the amygdala reacts to perceived threat in just 12 milliseconds. The prefrontal cortex, the reasoning center, activates nearly half a second later. In that gap, manipulation happens. Between fear and reason lies the space where influence is built. Imagine walking home at night and hearing footsteps behind you. Your body tenses. You move faster. But the moment you turn around, there's no one there. That's your amygdala in control. The same mechanism that made our ancestors run from predators now makes us share panic posts online. It's ancient software running on modern hardware, and those who understand the code control the reaction. But fear doesn't only paralyze the mind, it also makes us obey. The next layer of fear's control isn't in the brain, it's in our need for authority. This is the obedience reflex, where fear meets power. In 1961, psychologist Stanley Milgram set out to measure obedience. He wanted to understand how ordinary people could commit unthinkable acts simply because someone in authority told them to. His results shocked the world. Participants believed they were administering electric shocks to another person. Each time the learner answered incorrectly, the voltage rose from 15 to 450 volts. 2/3 of people continued to the highest level, even when they heard screams on the other side of the wall. No gun, no threat, just a man in a white lab coat saying the experiment must continue. Milgram's study revealed something terrifying and scientific. Fear of authority can override moral judgment. The brain registers authority through a combination of visual cues, uniforms, badges, titles, and contextual trust. When these signals activate, the amygdala triggers submission instead of fight or flight. It's a neural shortcut designed for survival in hierarchies. In evolutionary terms, challenging a leader could mean exile or death. In modern terms, it means we hesitate to question the person behind the desk or the microphone. Decades later, neuroscientists re-examined Milgram's findings with modern brain scans. They discovered that under orders, activity in the prefrontal cortex, the region for ethics and self-reflection, drops significantly. Obedience literally turns off the moral voice. The fear of disapproval or punishment is enough to silence the brain's own questioning. The obedience reflex isn't limited to laboratories. It appears every time a boss demands a deadline we know is unfair, and we still say, okay. It shows up when people obey trends they disagree with because everyone else is doing it. Social hierarchies still use fear as the invisible whip, not fear of pain, fear of exclusion, fear of standing out, fear of losing belonging. And in digital culture, where likes and follows replace approval, obedience is quantified in numbers. The lab coat has simply become a blue checkmark. History is full of examples where fear and authority worked hand in hand. Regimes didn't need millions of monsters. They only needed millions of obedient people afraid to say no. The psychology that once kept tribes united for survival became the same psychology that makes societies obey destruction. Today, authority doesn't always have a face. It's coded into algorithms, guidelines, and terms of service that most people never read. Each tap of "I agree" is a tiny Milgram moment, a click of obedience disguised as convenience. Technology doesn't command with shouting, it commands with design. And design succeeds because it understands our neural fear of being wrong, slow, or left out. Fear and authority work together to make people comply. But what happens when fear changes how we see reality itself? In the next part, we explore the framing illusion, how language and context quietly rewrite truth. The words are identical in meaning, but not in impact. Tell someone a surgery has a 90% survival rate, and they relax. Tell them it has a 10% fatality rate, and they hesitate. This is the framing illusion, the psychological bias that changes how we feel based on how information is presented. Fear isn't always created by lies. Sometimes it's created by context. In the 1980s, psychologists Amos Tversky and Daniel Kahneman demonstrated how framing affects decision-making. They gave people two identical medical treatments described in different ways. When the treatment was framed as a gain, most accepted it. When framed as a loss, most rejected it, even though both outcomes were statistically the same. The amygdala responds to wording faster than the logic circuits can calculate. Loss, death, risk, and danger trigger physiological stress before rational thought intervenes. Framing surrounds us. Marketing frames fear of missing out. Only 24 hours left. Politics frames security. Protect your family. Media frames uncertainty. Experts warn of possible danger. Each phrase bypasses reason and travels straight to emotion. The goal is not to inform, but to influence perception, to make safety seem urgent, danger seem constant, and calm seem irresponsible. MRI research shows that negatively framed language lights up the insula, a region tied to pain anticipation. Your brain feels words like crisis or risk as if a small physical threat is near. That's why even neutral information can feel alarming if the frame is dark enough. A single adjective can shift the body into alert mode. Modern media weaponizes framing through repetition. When every outlet repeats the same phrase, a surge, a wave, a crisis, the brain accepts it as consensus truth. Online, algorithms amplify the most emotional versions of each story because outrage drives engagement. The result? Fear isn't just an emotion anymore, it's an industry metric. But framing also works in relationships and self-talk. The sentence, "I failed again," frames identity as defeat. "I haven't succeeded yet," frames it as growth. Both describe the same fact. One fuels despair, the other fuels resilience. Control the frame, and you control the feeling. Fear doesn't only shape perception. It can become addictive, a chemical reward loop that keeps us coming back for more. In the next part, we explore the reward trap, how dopamine turns fear into obsession. Fear is supposed to repel us, yet somehow we keep seeking it. We check for bad news, watch horror stories, scroll through chaos, and then come back for more. Why? Because fear doesn't only trigger stress, it also triggers anticipation, the same chemical mechanism that drives pleasure. That chemical is dopamine. Dopamine is often called the pleasure chemical, but that's not quite true. It's not released when you feel pleasure, it's released when you expect pleasure. Neuroscientist Wolfram Schultz discovered this in 1997 when he studied monkeys predicting juice rewards. The brain fired not when the monkey drank the juice, but when it anticipated the juice. In humans, the same process happens with fear. When we anticipate bad news or danger, the uncertainty itself becomes a stimulus. The brain rewards prediction, even negative ones. This is the paradox of fear. It activates the same circuits as curiosity and excitement. When the brain predicts a threat, it releases dopamine to heighten focus, preparing the body for action. That's why scary movies feel thrilling, why we can't stop reading about disasters, and why social media notifications trigger anxiety and pleasure simultaneously. It's not just fear, it's the anticipation of fear that keeps us hooked. In behavioral psychology, this is known as the variable reward system. It was first discovered by B.F. Skinner in the 1950s. Rats pressed a lever not for guaranteed food, but for random rewards. The unpredictability created the strongest compulsion. Modern platforms use the same system. Every refresh, every scroll, every click to see more is a digital lever.
Sometimes we find comfort, sometimes outrage, sometimes nothing. But because we never know which, we keep pressing. The cycle looks like this. Fear creates attention. Attention creates dopamine. Dopamine rewards attention. Attention feeds more fear. It's not manipulation anymore. It's self-conditioning. We've learned to crave the very emotions that exhaust us. The brain doesn't care if the loop brings joy or panic, only that the loop continues. Over time, the constant spike and drop of dopamine reduces the brain's sensitivity. Studies from Cambridge University 2019 showed that people exposed to constant emotional content, both positive and negative, showed decreased dopamine receptor activity. The brain becomes numb to calm. Ordinary life starts to feel empty unless there's something to fear, click, or react to. And so entire systems thrive on our fear loops. Media corporations profit from clicks, tech giants profit from engagement, and our nervous systems pay the price. Fear has become entertainment, and dopamine ensures we keep coming back for the next episode. But fear doesn't just capture attention or obedience. It can permanently reshape how we see the world. In the final section, we explore the fear anchor, how trauma and repetition condition the brain to feel danger when none exists.
Fear doesn't just live in the moment, it stays. A single shock, loss, or warning can leave a trace that outlives the event itself. This trace is called a fear memory, and the brain uses it as a shortcut, a way to predict danger before it happens again. But like every shortcut, it can misfire, and when it does, the past becomes a cage. The foundation of fear conditioning goes back to Ivan Pavlov, a Russian physiologist from the early 1900s. Pavlov discovered that if he rang a bell before feeding his dogs, the dogs eventually salivated at the bell alone, even without food. He had accidentally uncovered associative learning. The brain links unrelated events through repetition. Decades later, psychologists extended this to fear. They found that pairing a neutral stimulus, a sound, a shape, a color, with a painful or threatening one, taught the subject to fear both. In 1920, John B. Watson and Rosalie Rayner conducted a now infamous study known as the Little Albert experiment. A baby, 9 months old, was shown a white rat. At first, he reached for it, curious and unafraid. But when the rat appeared again, the researchers struck a steel bar behind him. After a few repetitions, the child cried at the sight of the rat alone. His brain had fused the sound of fear with the image of innocence. The lesson? Fear doesn't need logic, only repetition. Inside the brain, the amygdala and the hippocampus work together to create this bond. The amygdala marks the emotional intensity. The hippocampus stores the context. Every time a similar situation appears, the amygdala reactivates the memory instantly. That's why trauma survivors react to sounds, smells, or sights that seem harmless to others. Their brain isn't remembering the event, it's reliving the emotion. In the digital era, fear anchors are constantly reinforced. Repeated warnings, visual cues, and emotional news stories retrain the brain to live in low-level anxiety. Even if no threat exists, the brain prepares for one. Over time, the body adapts to fear as its baseline, producing stress hormones even in calm environments. This chronic state of alert reshapes neural pathways, a condition neuroscientists now call emotional allostasis, the brain's attempt to normalize constant stress. A 2018 study from the Journal of Neuroscience revealed that fear memories can persist even when subjects consciously forget the event. The amygdala's response remains active, firing milliseconds before conscious recall. In other words, fear doesn't always live in memory, it can live in reflex. That reflex can be triggered by color, sound, time of day, or even the tone of someone's voice. Imagine feeling anxious when your phone buzzes, even if it's just a harmless message, or flinching at a tone that reminds you of someone angry from years ago. These are micro-anchors, small, silent chains that link the present to the past. Fear conditioning doesn't need trauma, only repetition and timing. But fear anchors can be rewritten. The process is called extinction learning, exposing the brain to the same cue, but in a safe environment. Each calm exposure rewires the amygdala-hippocampus connection, weakening the link between signal and terror. This is how therapy, meditation, and awareness help the brain reclaim peace. It's not the absence of fear, it's control over its activation. Fear shapes how we act, how we think, and how we see the world. But understanding fear is the first step to freedom. In the final part, we'll bring it all together, the science, the emotion, and the control, to show how awareness can break the cycle.
Fear is not the enemy. It was built to protect us, to keep us alive when the unknown was deadly. But when fear is misused, when it's triggered for profit or control, it no longer protects, it imprisons. The same emotion that once saved humanity can now enslave the human mind. Understanding that difference is the beginning of freedom. We've seen how fear moves through the mind. The amygdala hijack, emotion overriding logic. The obedience reflex, fear of power silencing morality. The framing illusion, language reshaping perception. The reward trap, dopamine turning anxiety into habit. And the fear anchor, memory binding the present to the past. 5 mechanisms, 1 emotion, and 1,000 invisible ways it drives us. The first step in breaking control is awareness. When you feel fear, pause. Ask, is this real or was it placed there? Every pause rewires the neural pathway. Every breath reminds the brain that it can choose response over reaction. Awareness doesn't erase fear, but it transforms it. It changes the amygdala signal from run to watch, from panic to presence. The truth is, the same brain that fears is also capable of compassion, creativity, and calm. Fear narrows vision. Awareness expands it. Once you see how systems, screens, and words manipulate emotion, you begin to separate the message from the mechanism. And the moment you see the mechanism, it loses power. Every day, the world will try to control you through what you fear. But the mind that studies its fear cannot be controlled. This is the science of fear and the beginning of awareness. If this video opened your eyes, share it and help others see too. Subscribe to PsychTube for more insights into the hidden science of the human mind. Stay aware, stay awake, stay free.